Okay, we've looked at some very simple log and exponential equations, but we're going to continue looking at some. Now, if you have of the form a single log equal to a single value, you're going to change it to exponential form and solve. So that's what we have here. So it's going to become 2 to the third equals 1 minus 2x. 2 to the third is 8 equals 1 minus 2x. Subtract the 1, so we have 7 equals negative 2x. Divide by negative 2, so negative 7 over 2 is x. Now, another special case is if you have a single log equal to a single log with the same base, you're setting the arguments equal. This is like the exponents we had. If you had the same base, you set the exponents equal. Well, first we need to bring that 2 up. So we have log base 5 of x squared equals log base 5 of 9. Log to the same base, we set the arguments equal. So x is the square root of 9, so x is 3. Again, with the logarithmic equations, we cannot have a negative number as either the argument or the base, so we're only getting a positive root. Okay, for this one, we have to, either of these cases, we need a single log. So we have to get this as a single log. So it becomes log base 5 of x plus 6 over x plus 2 equals 1. Now it's like the first type where we change it to exponential form. So 5 to the first equals x plus 6 over x plus 2. So multiply both sides by the x plus 2. You have 5 times x plus 2 equals x plus 6. So 5x plus 10 equals x plus 6. 5x is larger, so subtract x. We have 4x plus 10 equals 6. Subtract the 10. 4x is negative 4. Divide by 4. X is negative 1. Well, since x is a negative number, we have to put it back in to make sure neither the arguments will be negative. So negative 1 plus 6 is 5. Negative 1 plus 2 is 1. So it's okay in both. Okay, we need to combine the left side. So this is ln of x times x plus 4 equals ln of x plus 6. This is a case where we have single log equal to single log, same base, so we set arguments equal. So x times x plus 4 equals x plus 6. X squared plus 4x equals x plus 6. We have a quadratic, so we set it equal to 0. X squared plus 3x minus 6 equals 0. Oh, that's x minus 4. So this is minus 5x. So x minus 6. X plus 1 equals 0. X minus 6 is 0. X plus 1 is 0. x equals 6, x equals -1. We check the 6. We have ln of 6, that's okay. 6 minus 4 is 2, that's okay. 6 plus 6 is 12, that's okay. Check the -1, ln of -1. We cannot do it, so our only answer is x equals 6. So again, bring the exponent up. So log base 2 of x to the 3 equals log base 2 of 27 to the -1. So x to the 3 equals 27 to the -1. So x to the 3 equals 1 over 27. So x is the cubed root of 1 over 27. Cubed root of 1 is 1. Cubed root of 27 is 3. Combine. So we have log base 2 of x plus 7 times x plus 8 equals 1. Change to an exponent. X plus 7 times x plus 8 equals 2 to the first. So we have x squared. 7x plus 8x is 15x plus 56 equals 2. Bring the 2 over. So we have x squared plus 15x plus 54 equals 0. Factor would be x plus 6 and x plus 9, because 6 plus 9 is 15. So we have x plus 6 equals 0, x plus 9 equals 0, x equals -6, x equals -9. Look at it back in the problem. -6 plus 7 is 1. That's okay. -6 plus 8 is 2. That's okay. -9 plus 7 is -2. That is not okay. So x minus 6 is the answer. Combine. So we have log base A of x minus 1 over x plus 6 equals log base A of x minus 2 over x plus 3. Single log equals single log, same base. Set the arguments equal. We can cross multiply. So we have x minus 1 times x plus 3 equals x minus 2 times x plus 6. So we have x squared, 3 minus 1 plus 2x minus 3. And x squared minus 2 plus 6 is plus 4x minus 12. Subtract the x squares, they cancel. We have 2x minus 3 equals 4x minus 12. Move the 2x. So -3 equals 2x minus 12. Move the 12. So 9 is 2x. Divide by 2. 9 halves equals x. And that's acceptable, it's not negative. Now some more exponential problems like one we've done previously. If the base is the same, set the exponents equal. So this is 4 to the 2x plus 1 equals 4 squared. So 2x plus 1 equals 2. 2x equals 1. X is 1/2. If we have a single term with the exponent of x equal a single number, you rewrite it as a logarithm and use the change of base formula. Or you can take the log of both sides, which basically ends up the same way. We're actually going to do some one way and some the other way. So change to a logarithm and use change of base. This would be log base 2 of 5 equals x. So x is the log of 5 divided by the log of 2. So log of 5 divided by log of 2 is 2.3219. If we take the log of both sides and solve it that way, so we would have the log of 2 to the x equals the log of 10. Bring the x down in front. So we have x log base 2. Now, x log of 2 equals log of 10. Divide, we have x log of 10 over log of 2, which is the same as the change of base formula. So we have log of 10 divided by log of 2, which is 3.3219. Now, before we do any of this, either change it to a logarithm or take the log of both sides, we have to have a single number on one side. Single exponential equal a single number. So we have to get rid of that 8. So we're going to divide by it. So 3 to the x equals 5/8. Now, if we change to an exponential, that means log base 3 of 5/8 equals x, and x is log of 5/8 divided by log of 3. So we have log of 5 divided by 8 divided by log of 3, which is negative 0.4278. Now this next one is kind of hard to do, changing it to logarithmic form and solving using change of base, because we have two different bases. So for one like this, you do have to take the log of both sides and bring the exponents down. So we have x minus 2 log of 5 equals 3x plus 2 log of 3. Now we have to distribute. So x log of 5 minus 2 log of 5 equals 3x log of 3 plus 2 log of 3. Now we need to get the terms with the x in it to one side. So we have x log 5 minus 3x log 3. And we need to move the other terms to the other side. So this equals 2 log 3 plus 2 log 5. We need to factor out an x. So x times log 5 minus 3 log 3 equals 2 log 3 plus 2 log 5. So x is 2 log 3 plus 2 log 5 over log 5 minus 3 log 3. So 2 log 3. Now, parentheses, 2 log 3 plus 2 log 5, close, close, because we want to make sure the numerator is done before we divide by the denominator. So divided by parentheses, log 5 minus 3, nope, got the parentheses for the 5. So minus 3 log 3, close, close. And we get negative 3.2116. Let me put that in again just in case, because I got something different last time I did this. So 2 log 3, close, plus 2 log 5, close the numerator, divided by, open denominator, log 5, close, minus 3 log 3, close the denominator. Okay, I get the same thing, so last time I must have done something wrong, which does happen. Now this next one I'm just going to do with ln's just to show you that it's the same thing. You can use ln's as opposed to logs. So if we do the ln of both sides, bring the exponent down. You have x ln of 1.2 equals negative x ln of 0.5. Bring this over to get the x's together. You have x ln of 1.2 plus x ln of 0.5 equals 0. Factor out an x. Well, if we look at this and look at our zero product property, for this product to be true, either x has to equal 0 or ln of 1.2 plus ln of 0.5 has to equal 0. Well, we know these ln's were not equal 0. So that's telling us that x has to be equal to 0.